pretty good. Look at me freehanding a circle. Hey, it's better than my normal circles. All right. And then, shut up. Hey, look at that. All right. So a tangent touches the circle without going into the circle. Yep. Because I'm wonderful. And then if we have a radius, this must be a right angle. So that's going to help us. What types of things is that going to help us create? It could help us create an isosceles triangle. It's definitely going to help us make a right angle triangle, right? If I just create something like that, which means we can use things like Pythagoras, okay? So it's really important that we make as many right angle triangles as we can, just like in all the other topics. All right, so that's exactly right. So if you have the coordinates, you can find the length of the line, which we've been doing, which means that you can definitely figure out. Right. I mean, it's largely engineering based, isn't it? That type of thing. Okay, so let's have a look at when we might put this together with some of the other information that we have. So first of all, let's go back and talk about the discriminant from the first topic. Discriminant. I can't write and speak at the same time. What's the discriminant? Good. B squared minus 4AC. And when we're talking about a graph, right? How many solutions does this graph have? 2. Good. How many solutions does this graph have? 0. What do solutions mean? Right. So it means that it doesn't have any x-intercepts. Solutions are x-intercepts. So if I draw this graph, it's got 1. So what does the discriminant equal if it's the purple graph? It's positive, right? So the discriminant is greater than 0, correct? What about the green one? What do I know about the discriminant? It's less than 0. And what do I know about the red one? The discriminant is 0. Good. So if there's one solution, the discriminant is 0. We're going to use that information today. If I have 2 lines that equal each other and I end up with a quadratic, I can use my discriminant to tell me if there are more than one solution or not. All right, so let's do an example of that. I'm going to do an example. I'm going to show you what I mean. So, well, first of all, let's not do that yet. I just want to remind you of the discriminant. Let's get my list of things I want to show you out. All right. I am going to, nope, that is not, that is supposed to be me trying to move the screen a little bit. That did not work. All right, so I'm going to do question 7 in the book, okay? Because I'm not assigning you that one, so I'm about to do question 7. So question 7 tells us that y equals x minus k and x squared plus 2y equals k. All right, so what I'm going to do is the first thing I need to do, I am being told, what is happening? Is somebody doing that? That's disturbing. Okay. All right. So what I'm being told, okay, so let's, all right. It is someone doing it. John, you're so annoying. Boo, John. All right. So this equation, stop it, please. It's not you. Are you serious? Okay, excellent. All right. This is all on YouTube, by the way. Okay. What kind of equation is this?
Linear.
Good. It's linear. What kind of equation is this? Okay, this is a quadratic. Is it going to be smiley face, frowny face? How do you know it's a frowny face? Right. If that is brought across here, it's going to be negative x squared. So this is a frowny face. So what I want to know is this a tangent to this curve?
Yeah.
So first thing, what I'm going to do is make them equal each other, right? I need to know, do these things have one solution? So think about what we just did. Do they have one solution, 2 solutions, or no solutions? Isn't that what I want to find out? Because if it has one solution, what does that mean? It's a tangent. If it has two solutions, it's not. If it has zero solutions, it's not. So the first thing I need to do before I make them equal each other is do what with this? Rearrange it. So let's rearrange it to make y the subject. So this can be equation 1. This can be equation 2. So 1 is exactly, oh, actually, I forget that. Let's just do equation 2. All right. So I now have 2y equals k minus x squared. So then y is k minus x squared over 2. Now, I want to know when these two equations equal each other, what's the solution? So I'm just going to make them equal each other. So k minus x, I just said that backwards, x minus k equals k minus x squared over 2. See what I'm doing? Right? So 1 equals 2, right? But my rearranged 2, because I've got y as my subject. This is the substitution method, right? I'm just replacing the y's are going to equal each other. So then let's bring this across. So 2x minus 2k equals k minus x squared. You can see that this is about to become a quadratic, isn't it? So if I bring this across, I get x squared minus 2x minus 3k equals 0. Minus 2x, sorry, minus 2, plus 2x. Sorry, thank you. You're right, plus 2x minus 3k. All right, are you with me so far? If this has one solution, doesn't this equal 0? Okay, so how do I solve a quadratic? Oh, hang on, I think I've got more information in the question. Aha, all right, so I've missed a vital piece of information. Can you solve this right now? No, you can't. So what I'm going to do is give you another piece of information. I'm going to say that when k equals 1, oops, let's do that again. So when k equals 1, is it a tangent line? All right.
Just put k as for...
Oh, sorry, that's not what you're being asked to do. I'm reading the wrong question. When k is 1, okay, this is not a tangent line. So when k equals 1, the lines intersect at points A and B. What are the coordinates? All right, so let's find the coordinates. So if this is 1, this is just x squared plus 2x minus 3, correct? How do I solve a quadratic? Okay, I could use the quadratic formula, but let's just factorize it. Okay, x plus 3, x minus 1. So what are my solutions? Okay, am I done? Nope, good. Now I need to find the y coordinates. Ah, so those are my x coordinates. So I'm going to put that back in. So if y, where is it? Y equals k minus x, right? Or x minus k. Why do I keep saying that backwards? Y equals x minus k. So y equals -3 minus 1, because we said that k was 1. So y is -4. So that makes this coordinate -3, -4. And then let's do it again. So then y equals x minus k. So then y is 0. So then the next one is 1, 0. We'll live. All right, so these are the two coordinates where this line intersects this line.
Yeah.
Okay, I know that was a lot of stuff. All right, let's have a look at something else.
Determine whether it does much. Can we just make them equal each other and just not the discriminant of the equation that we get?
Well, that tells us how many solutions there are. It doesn't tell us what they are. But yes, of course. All right. What do I want to do next?